This chapter may be a little easier if you remember your sine, cosine, and tangent rules from Math 2. Now, we know this little phrase you might have heard is SOHCAHTOA. It's supposed to help us with which parts go with which angles or which trig functions. So here we are. We have a right triangle, which is really important if you're actually going to use sine, cosine, and tangent. I know the angle right here is 42. 13 is the hypotenuse. You should always know that that's the side across from the 90. Now, in terms of this angle, this over here is the opposite side. So being that I'm dealing with opposite and hypotenuse, I would go back and use the SOH tool, which is the sine. So I would say sine of 42 degrees equals opposite x over hypotenuse 13. Now, in order to solve these, I like to create a cross fraction, like cross multiplying setup. So I put sine of 42 over 1. We would take x times 1. And 13 times sine of 42. So 1 times x is x. 13 times sine of 42. It's important that you're in degree mode, so make sure your calculator is in degree mode. I'm going to take 13 times sine of 42, and that will give me x is approximately 8.699. Now let's try another one. Same rules apply. We have a right triangle here. I have angle 61. My opposite across from each side is 14. Notice how the hypotenuse is not even used or mentioned, so we don't need the hypotenuse in our SOHCAHTOA. This is our adjacent. So here's adjacent, and here's opposite. Remember SOHCAHTOA, the one that uses opposite and adjacent, is the tangent. So we'll say tan of 61 equals opposite 14 over adjacent x. Again, I make my problem look like cross multiplication. So I'm going to take 14 times 1, and that gives me 14, equals x times tan of 61. This one's a little different because you don't actually just get to multiply two things together and be done. You're going to have to do some division. To get my x alone, I'm going to have to divide by tan of 61. Still need to be in degree mode. So I would take 14 divided by tan of 61, and I'll find out what x is. So that makes x to be about 7.760. Again, taking 14 divided by tan of 61 gives me about 7. And that should make sense because that 7 here would fit right in. We don't ever want it to be, remember the hypotenuse is always the longest side, so you can do some checking there. Last example here. Of course, I've used sine now. I've used tangent. You can imagine I'm going to use cosine, but I'll put this little shortcut up here. We have angle theta. Okay. Now our angle's missing this time, but we still set it up the same. Opposite does not matter. Hypotenuse is here, 43. Adjacent is the 12. So when I want to use adjacent and hypotenuse, that is my cosine function, but this time you don't know the angle. Cosine of my angle theta, that's just a Greek symbol for missing angle, theta, equals adjacent 12 over hypotenuse of 43. Notice how we know both sides here. Well, back in Math 2, if you were missing an angle, you needed to use the inverse. I used to say, if you want to find an angle, you have to use the inverse. So on your calculator, inverse is like a -1. We're going to hit cosine inverse of 12 over 43. What that does, cosine inversing of cosine, this cancels, so you get to solve theta. But if you do it to one side, you'd have to do it to the other, and that's why we're going to do this to solve for theta. So make sure your calculator's in degree mode, and you hit second cosine, the blue button in cosine, and take 12 divided by 43 in that parenthesis. You would get about 73.795 would be your theta. And again, that's a degree. That's how many degrees this little angle is opening to.